According to National Electrical Code Section 250.104, non-electrical equipment is considered likely to become energized when it can be expected to be subjected to a voltage above ground or from other sources by normal operating conditions. This involves equipment that is intentionally energized or is part of an electrical circuit. Another way is through fault or abnormal conditions where equipment is not normally energized but can become exposed to electrical potential due to a fault or equipment failure. This also includes external sources, where equipment is not part of an electrical circuit but can be exposed to electrical potential from nearby sources, such as lightning strikes or electrical storms. The NEC doesn't specifically address the bonding of corrugated stainless steel tubing gas piping. However, manufacturers' technical bulletins may require additional bonding based on their assessment of the potential for the piping to become energized. One potential scenario where corrugated stainless steel tubing gas piping could become energized is if the equipment grounding conductor of the branch circuit fails. In this case, the gas piping could become energized if it's in contact with the grounded metal frame of the appliance. To mitigate this risk, the manufacturer's technical bulletin may require an additional 6 American wire gauge conductor to provide a secondary bonding path. Whether or not corrugated stainless steel tubing gas piping is likely to become energized is a question that should be addressed on a case-by-case basis. Factors to consider include the specific installation, the potential for fault conditions, and the manufacturer's recommendations. If there is any concern that the gas piping could become energized, additional bonding measures may be warranted. It is important to note that the NEC is the minimum requirement for electrical safety. Manufacturers may have specific requirements or recommendations that exceed those of the NEC. It is always advisable to follow the manufacturer's instructions when installing and maintaining electrical equipment. When looking at the NEC Section 250.104 addresses bonding other metal piping. This section mandates the bonding of interior metal water piping systems and other metal piping that may become energized. This bonding ensures electrical safety by providing a low impedance path for fault current, which helps to trip over current protective devices. The intention behind this requirement is to minimize the risk of electric shock. When an electrical fault occurs, any nearby metal parts, including piping, can become energized. Bonding provides a safe path for this fault current to return to the source, thereby reducing the voltage on the metal parts and lowering the risk of electrical shock. There are typically 3 main ways non-electrical equipment becomes energized. Firstly, normal operating conditions. Secondly, fault or abnormal conditions. And thirdly, external sources. Normal operating conditions refer to situations where equipment is intentionally energized or is part of an electrical circuit. For example, metal conduit containing electrical wires is normally energized as it is directly connected to the electrical system. In such cases, bonding is essential to ensure that the metal conduit remains set or near ground potential. Fault or abnormal conditions involve situations where equipment that is not normally energized can become exposed to electrical potential due to a fault or equipment failure. For instance, if a wire inside an appliance comes loose and contacts the metal casing, the casing can become energized. Bonding the metal casing to the grounding system provides a path for the fault current to flow, causing the circuit breaker to trip and to energize the appliance. External sources refer to situations where equipment that is not part of an electrical circuit can be exposed to electrical potential from nearby sources. Lightning strikes or electrical storms are prime examples of external sources that can energize metal objects. Bonding helps to dissipate the energy from these external sources, reducing the risk of damage and electrical shock. In the context of corrugated stainless steel tubing gas piping, the manufacturer's technical bulletins often require additional bonding beyond what the NEC mandates. This is primarily due to concerns about the thin walls of the corrugated stainless steel tubing and its susceptibility to arcing. When lightning strikes or a significant electrical fault occurs, the current can jump across the corrugations, causing small arcs that can weaken or even puncture the tubing, leading to gas leaks and potential fires. The additional 6 American wire gauge bonding conductor recommended by manufacturers is intended to provide a more robust path for fault current, minimizing the risk of arcing and ensuring the safety of the gas piping system. The decision of whether or not corrugated stainless steel tubing gas piping is likely to become energized should indeed be made on a case-by-case basis. Several factors must be taken into account to make an informed decision. The specific installation refers to the physical layout of the piping system, its proximity to electrical equipment, and the overall environment. For example, if the gas piping runs parallel to electrical conduits or is located in an area prone to lightning strikes, the risk of it becoming energized is higher. The potential for fault conditions involves assessing the likelihood of electrical faults occurring in nearby equipment. If the electrical system is old or poorly maintained, the risk of faults is greater. Additionally, the presence of sensitive electronic equipment that could be damaged by voltage surges should be considered. The manufacturer's recommendations are crucial. Manufacturers of corrugated stainless steel tubing gas piping have conducted extensive research and testing to determine the optimal bonding requirements for their products. Their technical bulletins provide detailed instructions on how to properly bond the piping system to minimize the risk of electrical damage. If there is any doubt or concern that the gas piping could become energized, it is always best to err on the side of caution and implement additional bonding measures. This might include installing additional bonding conductors, using surge protection devices, or consulting with a qualified electrical engineer. Remember, the NEC provides minimum requirements for electrical safety. Manufacturers often have specific recommendations that go above and beyond these minimums. When installing and maintaining electrical equipment, it is essential to follow the manufacturer's instructions to ensure the safety and reliability of the system. The bonding of CSST, or corrugated stainless steel tubing gas piping systems, is a critical safety measure that goes beyond the general requirements of the NEC. While the NEC provides a baseline for electrical safety, CSST manufacturers often specify additional bonding requirements due to the unique characteristics of their product. The primary reason for this is the thin wall construction of CSST, which makes it more susceptible to damage from electrical arcing compared to traditional black iron pipe. When electrical current passes through a CSST, it can create small arcs that can weaken or puncture the tubing, leading to gas leaks and potential explosions. To mitigate this risk, CSST manufacturers require a more robust bonding system that provides a low impedance path for electrical current, diverting it away from the tubing. This typically involves installing a dedicated bonding conductor, often a 6 American wire gauge copper wire, between the gas piping and the electrical grounding system. This conductor is in addition to the equipment grounding conductor that serves the gas appliance. The likely to become energized clause in NEC 250.104 is open to interpretation, but it generally refers to situations where non-electrical equipment could be exposed to electrical potential due to faults, lightning strikes, or other external sources. In the case of CSST, the risk of becoming energized is considered higher due to its proximity to electrical wiring and appliances, as well as its vulnerability to arcing. Therefore, manufacturers recommend additional bonding to ensure a higher level of safety. Several factors should be considered when determining the appropriate bonding requirements for CSST gas piping. Firstly, the length of the CSST run is a significant factor. Longer runs of CSST have a greater surface area exposed to potential electrical hazards, increasing the risk of arcing. Manufacturers typically provide bonding guidelines based on the length of the CSST run, specifying the size and location of bonding conductors. Secondly, the proximity of CSST to electrical panels, wiring, and appliances is another important consideration. CSST located near electrical equipment is more likely to be exposed to electrical faults or surges, necessitating more robust bonding. Thirdly, the type of electrical system in the building can also affect bonding requirements. Buildings with older or ungrounded electrical systems may require additional bonding measures to compensate for the lack of a reliable grounding path. Fourthly, local codes and regulations may have specific requirements for CSST bonding that go beyond the manufacturer's recommendations. It is important to consult with local building officials and electrical inspectors to ensure compliance with all applicable codes. The installation of CSST bonding conductors should be performed by a qualified electrician who is familiar with the manufacturer's instructions and NEC requirements. The bonding conductor should be securely connected to both the gas piping and the electrical grounding system, using approved fittings and techniques. It is important to avoid creating ground loops, which can interfere with the effectiveness of the bonding system. Ground loops occur when there are multiple paths for electrical current to flow to ground, creating the potential for circulating currents that can cause interference and even pose a safety hazard. The NEC provides detailed guidelines for grounding and bonding electrical systems to minimize the risk of ground loops. Regular inspection and maintenance of CSST bonding systems is essential to ensure their continued effectiveness. Bonding conductors and connections should be checked for corrosion, damage, and loose connections. Any deficiencies should be corrected promptly to maintain the integrity of the bonding system. In addition to bonding, other safety measures can be taken to protect CSST gas piping from electrical hazards. Surge protection devices can be installed to protect against voltage surges caused by lightning strikes or other electrical events. These devices divert excess voltage away from the CSST, preventing damage to the tubing. Proper separation of CSST from electrical wiring and equipment can also reduce the risk of electrical hazards. CSST should be installed in accordance with the manufacturer's instructions and local codes, maintaining a safe distance from electrical components. In summary, the bonding of CSST gas piping is a critical safety measure that requires careful consideration of various factors, including the length of the CSST run, its proximity to electrical equipment, the type of electrical system, and local codes. Following the manufacturer's recommendations and NEC requirements, and working with a qualified electrician can ensure a safe and reliable gas piping system. Understanding the principles behind bonding and grounding is crucial for ensuring electrical safety in both residential and commercial settings. Bonding and grounding work together to create a low-impedance path for fault current, which helps to protect people and equipment from electrical shock and damage. Grounding refers to connecting electrical equipment and systems to the earth, providing a reference point for voltage. Bonding, on the other hand, involves connecting metal parts together to create an electrically conductive path. The purpose of bonding is to ensure that all metal parts are at the same electrical potential, minimizing the risk of electrical shock if someone comes into contact with an energized metal part. When an electrical fault occurs, such as a short circuit, current will flow through the grounding and bonding system back to the source. This fault current can be substantial, and if the grounding and bonding system is not properly designed and installed, it can create dangerous voltage drops and increase the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding electrical systems, covering topics such as grounding electrode systems, equipment grounding conductors, and bonding jumpers. These requirements are designed to ensure that electrical systems are safe and reliable. Grounding electrode systems typically consist of one or more grounding electrodes, such as ground rods, crown plates, or metal water pipes, that are connected to the earth. The grounding electrode system provides a low impedance path for fault current to flow to ground. Equipment grounding conductors are used to connect the metal parts of electrical equipment to the grounding system. These conductors provide a path for fault current to flow back to the source, tripping the circuit breaker and energizing the equipment. Bonding jumpers are used to connect metal parts together to ensure that they are at the same electrical potential. These jumpers are typically installed around knockouts, conduit fittings, and other points where metal parts are joined together. The size of grounding and bonding conductors is determined by the size of the circuit they serve. The NEC provides tables that specify the minimum size of grounding and bonding conductors based on the overcurrent protection device rating. The installation of grounding and bonding systems should be performed by a qualified electrician who is familiar with the NEC requirements. Proper grounding and bonding is essential for electrical safety, and improper installation can create dangerous conditions. In addition to the NEC requirements, local codes and regulations may have specific requirements for grounding and bonding electrical systems. It is important to consult with local building officials and electrical inspectors to ensure compliance with all applicable codes. Regular inspection and maintenance of grounding and bonding systems is essential to ensure their continued effectiveness. Grounding electrodes should be checked for corrosion and damage, and grounding and bonding conductors should be inspected for loose connections and damage. Any deficiencies should be corrected promptly to maintain the integrity of the grounding and bonding system. In summary, bonding and grounding are critical components of electrical safety that work together to protect people and equipment from electrical shock and damage. Following the NEC requirements and working with a qualified electrician can ensure a safe and reliable electrical system. The discussion of CSST bonding often leads to questions about the specific requirements of different manufacturers. Each CSST manufacturer may have slightly different recommendations for bonding based on their own testing and analysis. It is important to always follow the manufacturer's instructions when installing and bonding CSST gas piping. Some manufacturers may require a specific type of bonding clamp or fitting, while others may specify the location of bonding conductors. Ignoring the manufacturer's instructions can void the warranty and increase the risk of electrical damage. In addition to the manufacturer's instructions, it is also important to consider the recommendations of industry organizations such as the National Fire Protection Association. The National Fire Protection Association publishes standards and guidelines for the safe installation and maintenance of gas piping systems, including CSST. These recommendations can provide valuable guidance for ensuring the safety of CSST installations. The bonding of CSST is a complex issue that requires careful consideration of various factors. There is no one-size-fits-all solution, and the appropriate bonding method will depend on the specific installation and the recommendations of the manufacturer and industry organization. Working with a qualified electrician and following all applicable codes and standards can ensure a safe and reliable CSST gas piping system. When dealing with electrical systems, it is always better to err on the side of caution. If there is any doubt about the proper bonding method for CSST, it is best to consult with a qualified electrician or engineer. They can assess the specific situation and recommend the most appropriate bonding solution. Remember, the goal of bonding is to protect people and property from electrical hazards. Taking the time to properly bond CSST gas piping can significantly reduce the risk of electrical damage and ensure the safety of the installation. The ongoing debate about CSST bonding highlights the importance of staying informed about the latest developments in electrical safety. Codes and standards are constantly evolving to address new technologies and emerging hazards. Electricians and other professionals who work with the electrical systems must stay up to date on these changes to ensure that they are providing the safest possible installations. Continuing education courses, industry publications, and online resources can help professionals stay informed about the latest developments in electrical safety. By continuously learning and improving their knowledge, they can better protect people and property from electrical hazards. In conclusion, the bonding of CSST gas piping is a critical safety issue that requires careful consideration of various factors. Following the manufacturer's instructions, consulting with qualified professionals, and staying informed about the latest developments in electrical safety can ensure a safe and reliable installation. The principle of likely to become energized extends beyond just CSST piping and applies to various other metallic components within a building's infrastructure. Understanding this concept helps in ensuring comprehensive electrical safety. For instance, metal water pipes, as mentioned earlier, are prime candidates for bonding due to their potential to become energized. They can be energized through direct contact with the electrical wiring, inductive coupling from nearby energized conductors, or even through ground faults in connected appliances. Similarly, metallic components of HVAC systems, such as ductwork and refrigerant piping, can also become energized. These components often run throughout the building and can come into contact with electrical wiring or equipment. Therefore, bonding them to the grounding system is crucial to prevent electrical shock hazards. Structural steel in buildings is another area of concern. While structural steel is typically grounded, it can still become energized under certain fault conditions. Ensuring that all structural steel members are properly bonded together and to the grounding system is essential for maintaining a safe electrical environment. Even smaller metallic components, such as metal door frames, window frames, and handrails, can pose a risk if they become energized. Although the likelihood of these components becoming energized may be lower, it is still important to consider their potential and take appropriate bonding measures. The NEC provides specific guidelines for bonding different types of metallic components, taking into account their size, location, and potential for becoming energized. These guidelines are based on years of experience and research and are designed to minimize the risk of electrical shock. In addition to the NEC requirements, it is also important to consider the specific characteristics of the building and its electrical system when determining bonding requirements. Factors such as the age of the building, the type of wiring system, and the presence of sensitive electronic equipment can all influence the bonding needs. Older buildings, for example, may have outdated wiring systems that are more prone to faults. In these cases, additional bonding measures may be necessary to compensate for the deficiencies in the wiring system. Buildings with sensitive electronic equipment, such as hospitals and data centers, may require more stringent bonding requirements to protect the equipment from voltage surges and electromagnetic interference. The bonding of metallic components is not a one-time task. It is an ongoing process that requires regular inspection and maintenance. Bonding connections can loosen over time due to vibration, corrosion, or physical damage. These loose connections can compromise the effectiveness of the bonding system and increase the risk of electrical shock. Therefore, it is important to periodically inspect all bonding connections and tighten or replace them as needed. In addition to visual inspections, electrical testing can also be used to verify the integrity of the bonding system. Continuity tests can be performed to ensure that there is a continuous low impedance path between all bonded components and the grounding system. Impedance measurements can also be taken to assess the overall effectiveness of the bonding system. Any deficiencies identified during testing should be addressed promptly to maintain a safe electrical environment. The bonding of metallic components is an essential aspect of electrical safety that should not be overlooked. By understanding the principles of bonding and following the NEC guidelines, it is possible to create a safe and reliable electrical environment for building occupants.